Hello everybody, welcome to another stream. How are we all doing? Right, so last stream we refactored the encoder system such that the types, just the type system was not really coded in the best way. So I've got like a single structure now for the type, each type. And so we can have a bunch of common fields, and we've just essentially done like a tag union with each kind of type. If it's a strut, enum, or an array, you get either one of these sort of fields here available. So yeah, we just did that refactor, and while I was doing the refactor in this encoder code generator, I kind of had a bit of a think about like, how do we handle if a structure changes version and if it's used in another structure that hasn't changed its version. So right now we have like each structure. This is the file that the user edits, but they can put it into dev mode and I'll like upgrade the version of that structure. But if it's used inside another structure, like how do you, how do you, like, it's no longer binary compatible. So you have to really upgrade this, the structures that it's used in as well. So it starts getting a bit hairy. And this is the database file that we produce, which maintains the versions of structures and things. And so it keeps a whole history of things for different reasons. And I think it's going to end up being quite a problem. So I was thinking about it over, I guess, Friday and Saturday. And I wrote up my thoughts on the Discord. And effectively what it's led to is I think I need to like just plan out the whole system, write out a bunch of documentation, and really think about everything before I carry on. Because I got to the point where... So I initially had a plan for what I wanted to do. I've now essentially exhausted the detailed parts of that plan. So now the rest of it's kind of not really thought about. So I think I want to sort of sit down and just plan the rest of it out. And then I guess that should be everything we need to just work on it until completion, really. There's a few things that don't quite make 100% sense. So yeah, there's not much that's going to change. We're going to keep basically everything we've done already. It's just we're going to define more of the system out and write it down, because it is a bit it is a bit complicated in some regards. So I don't want to forget anything. So I guess I'll just read this back just to sort of give myself a refresher as well, and so you guys are up to date. And then we'll get into actually writing up the documentation for it and making sure we've ironed out everything. So yeah, I've been thinking about the versioning problem, where if we up the version of a single structure, we'll probably have to up the versions of structures that it is used in as well. In one of the previous plans, we used to have a version per structure field, but that also had its own problems. So essentially, I think a new way that we can support versions is doing it per file. So versions will only be used for saving out files to disk, but they will be used for networking as well. But networking will mostly be breaking changes. There'll be no upgradability, right? So the reason why you have versions for files in this encoder system is so you can upgrade an old piece of data to a new layout. But for networking, we just want to know like, oh, the protocol version is version 6 or whatever. So that encoded format just doesn't need to upgrade, right? So it can be a breaking change. So the new plan is that I think each of our encode files should be a schema for either a single file, a network protocol, or a GPU or GPU basically. And we use it for GPU so we can like unpack and pack stuff and just generate code. So we can quickly edit structures and get like packed code really quickly. But yeah, the only file that will likely need multiple, or the only type of serialization out of file, network, and GPU that will need multiple files, that'll need multiple encoder files, is for the file type of serialization. Because we're going to have like a file for levels, a file for models, a file for animations. And instead of putting a strut in dev mode, we'll instead put the whole file into dev mode. And this updates every single type within the file. So the way I'm thinking about solving this versioning problem basically is every structure is on the same version. And whenever you do a version upgrade, you'll just upgrade every single file. Every single structure within the file. So currently, the problem with this system is if we delete stuff in a structure, you've got to put it into dev mode, right, which ups the version. So this could be quite problematic where we're going to get like so many different versions and like very quickly if we do it this way. And we don't want to have that be the way it works, because you'll explode out a number of versions, you have many structures that get generated and so many things to upgrade from. But there was this thing that I kind of like, I was looking at flat buffers and I was like, there's a concept called a table. And with a table, you could have like optional fields. And whereas a structure always stayed the same and couldn't be changed. But in my one, it could change if you upgraded the versions. So I thought the table thing was quite cool because you could add and remove fields. But it wasn't just a data structure you just pulled out of the file. It was more, it had like a bit set at the beginning or something, right? Or some offsets, whichever way you decide to implement it. So the table was a variably sized type, whereas the structure was a fixed size type. And this is where I was thinking I've not really defined this part of the system very well. There was still so many cases that I was thinking I've not solved this yet. So I got thinking basically, and if you remember in one of the previous streams, we implemented a thing called a CSON reader and a CSON writer. So this is basically our own C-like JSON, so it's a text file. And we also ran this sort of binary reader and binary writer. And it got me thinking, like, the binary writer will allow us to like pack data down and at the bit level, but it's kind of adds like, I don't think it gives us that much of a win over simply just having a data structure that you can just take a pointer to in memory, and then it's just a case of reading that data out directly. And if we wanted to do packing, we would simply use these packed types. If you remember, we've had these packed types where we take a primitive integer or float. You can say, hey, encode that to 8 bits, and you specify a range and it will just do all the packing for you. So we could already do some kind of packing and also have a direct, these would just get compiled out to some kind of like array of U32s or something like that, depending on how many of them you need. And and there'll be some functions to like basically read those back, or to unpack them. So yeah, I was thinking by packing them using this binary writer and binary reader, it's going to get a little bit like there'll be more code that's generated than necessary, and we're only probably saving, you know, a few KB or whatever, maybe megabytes, I don't know. And it'll just be easier if we just generate the structures and maintain versions of structures instead. So we solve that problem. Now, wherever we put the whole file as being a single version, and they change these structures, you have to up the version of the whole file, and it will happen a lot. So I guess let's read through this thing here that I wrote, and it will solve all those problems. Yes, I've been thinking about how we're going to get tables, which is that variably sized type, and structures working across 3 different types of serialization, which is files, networking protocol, and GPU. And the bit packed table concept just makes things too hard with very little gain. So I'm thinking of dropping that table concept in the encoder file. Tables also made it such that we could add and remove fields without upping the version. But this can be achieved as structures. This can be achieved with structures if we only export to text files and don't allow binary. So the great thing about exporting to JSON or my custom version CSON, if you export to a text file, fields can be missing and fields can be added, and they will simply just be ignored, right? Like, what's the way of saying it? So if they're in the CSON file, like the text file, and the field itself doesn't exist, we just initialize it to the default value. If there's a field that we don't know about, we just simply won't read it, right? So that's where text has the benefit. So we still would like binary files though, obviously, because they're fast, but you know, text files for development basically. Hey there, Wajilla, how are you? How are you, my friend? I saw you got your mesh system going. Congratulations. So I'm proposing a new plan. We're going to have structures, tagged unions, which I haven't added yet, but they're just going to be very easy to put in, and enums. In development, we only serialize out to text files, enabling structures and unions to change without bumping a version. While in text development mode, we will not be able to change data types of fields, only add and remove fields. But fields aren't technically removed, they are going to retain there in that database file, which we've already got. When it comes to shipping something to users, we switch to binary development mode. If anything has changed, it bumps the version, allowing us to update from previous versions and previous text development versions. Then we convert all the assets to binary, test, and release. When it comes to struts, unions, and enums, I now think we should literally read in the whole file, verify the checksum, return a pointer to the root object. There will be no systematic decoding process or encoding process, just decoding of bit fields done via code-generated functions via those packed types that we saw earlier. For the variable length arrays, these will just be a U32 offset, which is relative from the field itself in memory. So when we're serializing out the file, we've got the size of the root object, we place it into the buffer. Any variable length arrays, we simply just bump allocate after that, and we just patch those. We just store we bump allocate them basically into that buffer and make sure that relative offset points to the right place. bit fills will only be allowed in struts with the hash bit fill directive. I see. I'm not sure about this. I might change my mind on this. But we'll still have the bit fill directive so we can know what to pack them in. But each bit fill can span over 2 or more word boundaries at the cost of an extra decoding performance. Only pack type. No, ignore that one. Hey, Pratik, how's it going? Which camo are you using? I'm using the Anchor work something. C something. It's pretty decent. I forget which one it is exactly. Posted it on my Discord. I need to find it. Anchor work C310. Doing well, good to hear, Wajilla. Good to hear, my friend. All right, where did I get to? Yep. For networking, and I have one of these on the GPU, it's common to have the packet that ends in a union, and you only serialize up to the end of the union field that you have actually written to, and not sending the useless padding bytes to the end. We should support this by generating a function which dynamically calculates the size that is required based on the tagged union field. And we should support hash packed so there can be no padding between bit fields. So we probably, I don't know if you guys have seen Pragma Pact, we should probably support that. Yeah, I think that is cross-platform, so we'll support that. So yeah, so this design also super great for GPU land. No text files in GPU. Basic types and bit fields in structures. Their word size is strictly U32. We do support. The GPU does support 16-bit types and 8-bit on some of them, and it does support 64 on some of them. But it's just easier to stick with just 32-bit stuff. If you want to support them a wider range of hardware, for now, but in the future that's not going to be a problem. I'll also skip support for unions for now until we actually need them on GPU, because on GPU you need pointer support, and I don't really have that yet because it's not really cross-platform, so I've not really done it. It's in Vulkan, but I've just not really bothered doing it. So you can either have a U32 pointer to a buffer and then an offset into the buffer that you decode from. If you just decode a field of a union, or you have a structure that houses a union, which is an array of U32 that you decode from, right? Because if you try and simulate unions, you need to basically have an opaque array of U32 words that you manually decode from, right? And that's just obviously quite a weird thing, and we don't really need it yet, so we won't bother doing that. But yeah, for networking, we want to have text files, but we'll have version numbers, but we'll never want to upgrade them. You can think of this as a protocol version. Right, so we're basically there now. So for GPU, the encoder system for GPU, we want version numbers. Where do we? But we might serialize out some of the struts disk that get loaded straight into GPU memory. Yeah. So I have had a thought about that one some more. And the way that I look at it is that when I need it, we will add support for this, but I do not think we need it. and we might not ever need it. So we're not going to bother doing that one. So what we're going to do is I've got this markdown file. It's called, it's Encoder. So this is going to be the documentation for the encoder system. There we go. So I want to think about everything to do with this system and make sure it makes 100% sense before I carry on and write any more code, so that I can just clearly execute a plan and not be sort of like start working, oh crap, I have to think about this thing I didn't think about, and keep doing that. I'd rather just I got to a place now where I've got a system together and I like what we've got so far. The rest just needs to be ironed out. So we have this .enc file. There's 3 different target modes. One is file, so you're saving that to the file system. One is net, it just means you're encoding into a buffer and sending it over the network. And one is GPU. And GPU just means you're trying to pack stuff down, because on GPUs usually reading the same, you are usually reading the same data across different compute units, and this uses up space in caches. Also, memory bandwidth is the first major problem to solve usually. So packing data down as small as possible is usually the way to go for a lot of GPU algorithms. So this is part of the reason why I want this system to work, is so I can just like tweak stuff, if we were to manually write unpacking and packing code, is error prone, takes time, when you want to sort of jam on stuff. And this is the main problem the encoder system solves for GPU use case. The GPU use cases. For files, obviously we're building an editor, right? We have an editor where we make custom assets, right? And saves that to disk. We also would like to save, extend we'd also like to extend or like to add more features and make changes without losing assets that have been made. Already been made. We would also like to be able to ship binary files. Okay, we would also like to be able to use text files in development. So we would like to be able to use text files in development so we can visualize the data better. And to be able to ship binary files of assets for speed per, speed and size reasons. These are the sort of problems that the file encoder are going to solve, right? We want to be able to, obviously, the goal is saving custom assets to disk. We want to be able to add features and make changes without losing assets. So some upgrading scheme needs to be in place. We'd like to be able to use text files in development to visualize data better and be able to ship binary files of assets for speed and size. Networking. For networking, we'd like to be able to basically, it's kind of like GPU, right? You want to be able to pack stuff down into a small space and send it over the wire. So having something to help with that would be kind of cool because, yeah, it's kind of error prone and we can just make changes quicker. And we'd like to. Yeah, so with networking, we will, or when writing network, so I've not written much of this stuff myself, I've only tried to do it once. But we will be doing it in the future, probably peer-to-peer, you know, so you do some co-op basically and play with your friends. So yeah, it basically will, yeah, we probably wouldn't have to do that much of a, Yeah, so I think the better the job you do packing the data down, the more chances are, like if packets go missing and things, the more of your data actually makes it there. You know, there's lots of reasons why you want to do it. Yeah, when writing network packets, you benefit a lot. Yeah, there's lots of reasons to pack it down. Also, if you're running a server, you want to be able to like, you know, there's cost to sending stuff, basically. But we won't be running a server. So maybe you'll help. Yeah. I guess you'll help people play your game more instead. You benefit a lot from packing your structures down. Let's keep this one bare. Packing structures down. You know, it'll be nice. Before sending them. Or send them over the wire. This will help you send less data and reduce the likelihood or reduce the amount of data that goes missing. And then it has to be reset. Something like that. Something like that will do. Cool, so there are 3 different target modes. So the idea is you make a .enc file, you put at the top hash file, hash net, or hash GPU, and it is specifically meant to be used for these 3 scenarios. If we need more scenarios, we'll add them, but I think this is what we'll do. So down below, we've got these sort of target mode features. So these are things, so I don't know what I should call them features, but we'll see. But these are things, are aspects of the encoder system that change depending on the target mode. So like, I started writing this out yesterday because I was like, I wanted to get a head start on this. So we'll just read over it quickly and then we'll maybe add some more. So for the variable length arrays inside structures are only supported in the file target mode. Since they work by encoding a U32 relative offset from where the field is. So yeah, when we're encoding the data out, we just take pointers to structures, we put the root object out, and it's got some relative indices in there. Every single time we're trying to do a new array, we bump allocate it after the root object and just make the relative field point to that, point that many bytes ahead. For files, this is very easy to achieve. Okay, I've already I say it in here. For files, it's already very easy to achieve since we just bump allocate arrays after the root object. But for networking target mode, the packet size is only about 64K from what I researched. So other techniques just work out better, right? Just fix allocating the max size, or and only sending the maybe we might do variable length array ones. We might revisit that when we actually do networking. We'll see what happens. And for GPUs, buffers are typically a single type, right? You have a buffer of uint, a buffer of some structure, and supporting multiple types is not really a thing. It will only really work if we did an untyped G32 buffer, which we reconstruct everything. Where we reconstruct everything, and I don't see a use case for this at this time, but we can always add it in the future if we want to. So variable length arrays will only be a feature that works in the file target mode. CSON, this only work in the file target mode. I was thinking like binary, we might like to have I'll think about that one. But it's just right. So CSON is our text format. So files are, so the file target mode only really supports text because sending text over the network, if we wanted to do that, we can add that into the packet type as an array of bytes, right? We're still supporting an array of bytes. We can always send text over the network. That's not a problem. It's just mainly like the whole thing, like the whole file, text file, sending that over, like, what's the way of saying it? If we have a data structure and we serialize that out to a text, it's not going to be a network protocol, if you get what I mean. Text, it's always going to be binary based. So yeah, GPUs, we're not parsing text on the GPU, so obviously don't need it on there. Yeah, so I was thinking, right, so for the file target mode, we could maybe want a type that is a file that is always binary. So what could this be? Well, if you have like a image file as an example, they're binary, right? You don't have a text file of pixels. But the whole point of using the text file is so we can change fields really easily without having to bump the version number. So it makes me think, would we like a way to specify for the file target mode? This one supports a text mode and this one doesn't support a text mode. Maybe just have like an array of, like, imagine if you want to make a mesh format, for instance, and you have an array of vertices, an array of, you know, yeah, I think we might want to support it for stuff which just doesn't work well with text. Like, so we've got to have a way. So we'll think about this one. Should I do it now though? Yeah, so the top of the file, the encoder file, we do that hash file. Yeah, so when we do like let's go to the encoder files. So at the top now, we're going to have like the target mode. So you go target file, right? So it's, right, or you have GPU or you have net. So we say file, and then afterwards, we could say text/binary or just binary or just text. Yeah, maybe that's what we do. We can write the documentation for that. So I think that sounds pretty legit. Let's oh, it's the thing anyway. So so there's a file can choose to have a okay, let me change this a bit. We would also like to be able to use text files for development so we visualize data. Like we also like to would also like to we'd also like to use text files most of the time in development to help visualize data better, and to be able to ship binary files for assets speed reasons. Right. So a file can choose to be a text choose to have a text and or binary file. In the target mode directive itself. So we'll put the code block in here, just as the example. So target file. So if you just did text, right, you would only get a text file. Only get a text file. So so you'd still get the data structures because the whole point of the text file is that it will be decoded into the binary file anyway. So maybe you always get the binary file. Yeah, this is why I wanted to think about it beforehand, because there's lots of little questions to ask. So you'd never want to ship text. Maybe. Say if it's like a file for like a configuration or something, you want to ship the text. So you never really want to ship the binary. Would you? Yeah, so you only get a text file. Yeah. Yeah. Signal. Yeah, so only code generate. Yeah. I'm not sure if there's going to be any special code for binary. Maybe we can write like a Boolean out or something to say like, can this thing be used for binary or something? I don't know. Maybe there's ways to safeguard it. But let's just say if you do text, it means only sort of data types are only exported as text. I'll put in brackets CSON. Target file binary data types are only exported as binary. So maybe we should write like special they're not text and binary. So data types are exported as text in development and released in binary, something like that. Yeah. So my right. I think we should do a separate bit of documentation for each of these. So we'll say so say this should be used this should be used for things like configuration files. Maybe we won't put it as a comment thing. This should only be used for things like configuration files, where you would like the user to be able to edit these in the shipped version of the game. Right? Whereas like for the binary one, some data just isn't. Data types are only exported as binary. This is useful for data that simply isn't well suited for text, like mesh data mesh and texture data, pixel data. And only when the format, when the structure or the types do not change that much, right? Because you lose the ability to, as with a binary format, you need to update the version more, right? As with a binary format, is also for text, like mesh and pixel data. It should only be used when types used for types that do not change much, comma, as with a binary file, you will need to up the version for every set of changes that you make, right? For every time you enter dev mode. No, not into dev mode. For every time you want to make changes to the format or to the data layout. Yeah. Cool, that's great. So I guess if there's stuff that makes changes a lot and the data isn't well suited for text, hopefully that's not a case, but if that's some case, maybe you just probably have to pick between which is the best trade-off to make, basically, at that point. Much better. The main light on. What a wally. Right, so target mode file with text and binary support. Data types are exported as text JSON development and released in binary. So I think the way we want to solve this one is you basically just can make any change you like. In the database file, we're obviously going to keep track of the history or what fields have been removed and things. We'll keep them in the database. So you can add and remove them. You can and stuff like that. And then where was I? So data export is G. Right. Yeah, so how do we go into the... So when we want to ship the binary one, yes, I think you'll remain in... So when you've got this text binary mode, you're going to be in text and then for development. Then when you're about to release the game, you want to kind of put it into a like... let's go to one of these files. So when your whole file is in development mode, we're not doing this dev mode thing anymore like this. We should probably get rid of those. It's not confusing. So in your whole file, so you're developing your next version of the game, you can just literally delete things and that, delete fields and add new fields. And maybe to get around the problem of not having to up the version, you just yeah, no, you might have to upgrade it sometimes. Yeah, so you need to have a case to upgrade whilst you're in this sort of text mode for development. And then when you switch over to binary, you might want to still obviously make some changes too. Right, so how would you, so I think you could put so the file won't be in development mode, but you'll just be making text or whatever. Sorry, your primary target will be text. When you want to ship the game, you could put it into dev mode. Right, so you put it into like a dev mode. That will then, so say if you was on version 0, you've added some fields, basically, and you've got you've added some fields in the encoder file, and you've saved out some assets already under this version 0 with sometimes they've got fields that don't exist anymore, but it's a text file, so it's fine, right? So when you put it into this dev mode, you're saying, right, version 0 is now done. We're moving to version 1. This is where you get to finalize your binary file, but also make the changes to the data types. You'll get the version upgrade stuff, and you could choose to make the release with this one after you got it all working, or you can just delete the dev tag and get back to going doing text again, because you might have just changed a field data type and you wanted an upgrade path. Yeah, that makes 100% sense. So I think, right, so where can I document this though? So maybe it works the same way as the binary one, right? You just put it into dev mode. That would be great. Yeah, okay, so I think we can write that. We can write that down. So we could stick that down. I'm not sure where I'll put that documentation, but at least we've thought that out. Data types are stored as text, CSON, and development, and released in binary. You know, this works extremely well when your data types change a lot and representing them in text. And if they are represented well in text. Cool. We should probably say text here, because this is a text file. Adding and removing fields. Adding / removing fields. See, I'll be repeating myself in like a few places. Maybe we should put Yeah, so maybe we should put it before, and then we won't have to repeat ourselves so much. So perhaps we can just say like, you choose file to have text and or binary in the target directory itself, right? So here we'll say, should we put a thing for like versioning? Versioning and upgrades. And then or I can just write another paragraph that just answers it all. So, you know, text files, CSON shines. When data is encoded as text files, the encode system will allow you to change, allow you to add and remove fields. Ooh. Allow you to, then bullet points. Add and remove structure fields, strut/union fields. Yep. It will allow you to add and remove enum. Values. But it will not allow you to reuse an old removed field name strut union field name with reuse. You can reuse an old remove strut union field name with the same type. Right? But you can't do it with a different type. And the other thing you can't do is change a strut/union field type, right? Yeah, I think we won't add renaming support for a while. I'll just get the version out. Maybe we could have renaming support. That's something to think about. Yes, you can add and remove strut fields. There's another one as well. So add and remove. Yes, you can't change. You cannot reuse. Right. So if an enum value, say with use enum value 2, and it's for a dog, right? You can't go and you can't go and use a different name for the same field because you would serialize old data you deserialize old data into the new enum value with a different enum name, and it'll be confusing. So we won't be able to add. So you cannot. But it will not allow you to. Yeah. Yeah, I guess it's reused an old removed enum value with a different name. With the same name. Yeah, that's it. Right. So when data is encoded as text files, the encoder system will allow you to do the following. The encoder system, or you can do the following. The following changes without updating the version. Add, remove struct union fields, reuse old, removed field names with the same type. Add, remove enum values, reuse old, removes enums with the same name. But you will not be allowed. But the following will require updating the version. Change the struct union field type, reuse an old, remove one with different type, and remove an old. Sorry, reuse an old. This is what old is. Just reuse a removed enum value of a different name. Which reads a bit better. Cool. Nice. So that means yeah, so we'll do one for the binary one now. So when data is encoded as binary, it's encoded as when data is coded as binary, you can do the following changes without updating the version, and that is nothing. Basically, you can't make any changes. Well, I was thinking we could add like rename support maybe, or aliases at least. Yeah, something to think about. It's coded as binary. Yeah, the only thing that you'll probably be able to do is change a field name. But if you change a field name, it could be encoded as text as well. So this would then mean yeah. Okay. When data is coded as text files, CSON, you could make the following changes without updating the version. So you could change. See, if you just change the names of things, you'd only be able to do that in a binary only target mode type, isn't it? Really. The rest would be aliases or something. Yeah, let's not bother thinking about rename yet. Yeah, you could do rename when you put it into dev mode, I guess. Rename a field. You cannot rename a field. Struts as union field. Or enum value. Rename enum value, you can't do that. But you can do renames in the upgrade step. Yep. So, say if I want to do a rename in binary target mode. So if it's binary in text, yeah, so I guess you can change the name. Rename a strut/union field, and you can also rename. I don't know if you can rename data types. That's not a thing. We won't be doing that. Just rename the field would probably be good enough. Rename. Because it was saved out as text in the past, you can't. You've got to have like an alias or something. It's a bit weird. Right, so those are things you can do without updating the version as binary. That's the benefits using binary. But the following will require you update a version, and that is basically everything. Adding, removing fields, adding and removing enum values. Wait, you can always add. So if you add enum values and you load that up in a past version, we've simply not what can we say? We don't have those enums, they're out of range, so we don't process them. You're gonna get that with this anyway. So maybe you can add enum values, right? But yeah, you can, to remove an enum value. Well, what do you get if you remove one? Um, Guess we can choose how to handle that some other way. So if you have a binary file, the following changes will require you to update. If we remove an enum value from definition and you load that in, it's one that you haven't actually got. So when you do switch statements and that, you've got to really handle your defaults. But you're doing that anyway if you can add new ones. So maybe you can add and remove enum values. That's probably safe. In that regard, so you can't add and remove structure fields. Wait, if you can rename enums at this point. Yeah, I guess you can rename them. Yeah, I don't ever really want to do with the binary one though. Maybe. Because if we allow you to change the enum and you don't up the version, you've got to handle all these sort of like unknown enum values in your code. Whereas I guess you should really handle that anyway because of like security reasons. So I guess it's okay. So you can do renaming since we're not serializing out the text string of the enum. Reuse a removed enum value with the same name. Yeah, you can do all that. You can rename, do whatever. So the following will require an update if you change the data structure of the or the union. So any fields or that get added or removed, you got to do an upgrade. Reuse. So enums are completely off this list. Change the field data type. Yep. Okay, so really, actually, now that we've like written it out, the binary format can actually be edited in a different way. So they've actually got different. I was thinking the text file is like this one that could just be super, was super flexible, but it really benefits to allow you to change the structure, whereas the binary file enables you to rename things in a structure and add and remove enums and rename enums. You got to be careful though to not reuse a removed enum. How can we do that? Because this is very error prone, right? If we had one called like dog is 2, right? Then we deleted dog, and then we was like, you know what? We've got bunny, and bunny is now 2. But we already saved data out with and your dog will now be a bunny, and that won't be ideal. But then you get to rename. Yeah. So maybe we do limit the binary file and just say that, you know what, you can't add and remove enum values because you have to change the version. Right, because when you add and remove stuff, yeah, I think we'll do that. We'll support renaming. Because renaming is kind of nice, being able to do that. But you won't be able to add and remove stuff. Maybe. Hey, no idea. How you doing? It's been a while. It's good to see you. How's life going? I saw you awoken from your sleep in the Discord. I was like, well, no idea. Yeah, I think this binary file is probably better off if we support the renaming. See, or we could just support nothing. Because say if someone's got a version 2 of an asset and they've added new enum values, yeah. Right, I'm keeping with the renaming thing. That's pretty good. So we could talk about like how we up the version and things. Probably inside these different target modes. I think that'd be a good idea. A bit better, getting much better, or getting some better sleep, and have more energy. That's very cool. Well, amazing. Have you adjusted your diet by any chance? I find if you basically cut down your carbohydrates and cut down your carbs and eat more fat-based stuff. I like energy all day. I don't like crash. But yeah, when you go into the supermarket, you try and buy anything, you're like, I can have nothing. That's kind of the problem with it. But it's good. Not more energy. Although I still wake up in the morning like a zombie. Had to change quite some habits. Only light food in the evening. Quick coffee. Oh, zero caffeine regimen. Legit. Yeah, caffeine's one of those things where like you get dependent on it, isn't it? Try complex carbs like basmati rice, lentils. What's a complex carb? Yeah, I still eat carbohydrates. I just don't eat them much. So for breakfast, I just eat meat and veg. Lunch, meat and veg, and then dinner I eat whatever my wife cooks. Cooks us for the week, and that does me good. So I just sort of really bring down how much carby stuff I'm having. Yeah. So we still have rice and stuff. Like, we should do like a nice spicy rice. You know, still have that. Right, so this is interesting. So the target file mode, when it's text, right, when you enter dev mode, you just make the changes. Yeah, so I should probably talk about dev mode after this. So we could talk about versioning and upgrading or something like that. Versioning and upgrading. Words. So basically, you know, when you need to upgrade your file, use the hash dev directive, or place the following. Place the following underneath the target, the hash target directive. Right. So dev will it will up the version. Will up the version. See, I wonder if we should have do our things where we do like would you ever want to say no upgrade and just reset everything? Maybe. And potentially could be helpful. Yeah, so I think we have those different modes. Oh, we've already got those. Well, you're mostly on a ketogenic diet. Meat does me no good, so I eat really low fat instead. Oh, interesting. You're like the complete opposite to me. I think that my problem is I lived off very high carb and high sugar diet for so long that it's not done my body good. So yeah, going the other way seemed to be a good solution for me. But yeah, it's interesting. But I'm glad you're seeing benefits from that. Do you have to stick to very specific carbs and things? I guess you stay away from sugar as well, right? Because sugar's really, spike. You get a sugar spike and crash pretty hard. Tell you what though, when you have a bit of sugar and you haven't had it for ages, man, it just brings music to your ears. Like the overwhelming happiness, and it's insane. Such a dopamine hit. What I'm working on. Yeah, so effectively what I want to be able to do is I've got this custom file which basically looks like C. Ignore this table thing, I'm getting rid of it. It's a terrible idea. But the basic idea is we can declare data structures and it will allow us to, it will code generate text encoding and decoding, as well as binary structures that we can use to sort of take a pointer to a binary buffer and read and write to it, basically, as these data structures. So I was going to do a binary encoding where I bit pack everything, but now I've decided I'll just take pointers to an area of data and traverse it manually. Because yeah, I think that'll just be better. But the main benefit of this thing is we get like a sort of like a packing solution. So you can say like, hey, I got this U16 value that I want to pack down into 8 bits within this range. Or I got this float 32 value I want to pack down into 8 bits within this range. As an example, and this will do the essentially like bit fields, but just nicer. And it'll generate it will generate unpacking and packing code for a structure. So when we have like a pointer to it or something, or by value in GPU land, it will just generate the packing and unpacking code for us. So it'd be very easy to edit and won't be as error prone. And the thing I want to use this for is for writing files to disk with versioning and upgrade support. But I also want to take the packing stuff and make that work on GPU, because GPUs obviously benefit from really packing stuff down, and I don't want to be spending a lot of time just getting that stuff right, because I've done it before on this project and it was just kind of error prone and I got stuff wrong. And it's a bit, fiddly. So to make it less fiddly. And also support networking in the future. So I've been thinking about that. So yeah, that's basically what we're building. I've written at the the parser already. So we've got a parser, we've got a little database file as well, where it sort of keeps the history of like structures that I've done and changes that I've made. So this has got a version per strut, but we're changing it now so we have a version per file, and the file will only write to a single file, if you will, single asset file, or single type of asset file. Yeah, so that's basically what it's for. It's a system for a few things, but mainly packing and unpacking with a bit of versioning sprinkled in there. Because I'm going to be building like an editor where we can make assets in, so I want to be able to like upgrade these things. But yeah, it's the system. So we're just planning it all out right now, because I planned out initially, we've executed on it. I got to a place where it needs a little bit more thought and refinement, because where the direction I was currently going would not succeed as well as I'd like. So I've just done a slight pivot, and yeah, it's good though. Not much, is only if two small things got removed. The binary serializer, although we're not packing stuff down anymore, and tables have got removed, and we're just doing structures and unions. Tables were like a variably sized type. Yeah, we're not doing that anymore. So yeah, I'm just trying to define all the rules out, so I don't like have to think of this when I write any more code. So I could just plan out the rest of the system and just hopefully execute until it's done. So let's run out all the rules so I can refer to it later. So for files, we have versioning and upgrading. I think you'll need to place. You will need to place the file into dev mode. It has the following options. So hash dev upgrade. You'd like to upgrade from past versions. See, what are we doing for that now? Yeah, I think the system will need to know about it. Dev, no upgrade. So all past versions. So we can say this route will retain past versions. See, maybe we'll keep them in the database anyway, but it won't generate them. You'd like to discard all past data and start from scratch. And then the other one is amend. Ups the version number and you will upgrade from past versions. Ups the version number, file version number, and you and all past data will be discarded. And started from scratch. Amend. So this will keep the same version. Keep the same version. Yeah, but it's very risky if you already created assets with this. But risky. But you must. It comes with low glycemic index, complex carbs, carbs with fiber, no refined sugars. Right, gotcha. Right, yes, you're doing like the more sort of like natural carbs, isn't it, basically? Right, I see. That's the way to go, isn't it? Just in the way food is typically sort of grown. Not anything processed, basically. Keep the same file version number, but you must revert. Any data is not. Revert your assets. So they can be updated. Yeah, but it's not necessarily updates. So you don't load any invalid data. Made with this version, something like that. So you could put the git hash in or something like that. See, this is the thing where it's like we're not really solving the cross branch problem. You know, you do 2 upgrades on different branches or something, but if we store the git hash in the database file for where you've done the upgrade, I wonder, could we say if you got 2 different version 2s from different branches, and then you merge them in or whatever. They'll obviously have different Git hashes in the database file or something that they were created with. You could then say, yeah, so I think we'll leave the Git hash in. Then we could make a system or make a change to this encode system, which will allow you to take two branches with different versions and then merge them into the new one or whatever. Or sorry, two branches of the same version that would generate with different data layout and merge them into the same one. That would be possible. We're not going to do that yet. But so we'll encode the Git hash into the database file. Oh, neat. The bot did it. That's cool. So, yes, we need to write a little bit more. So you place, this is done like so, right? It has to be done under the target, right? Dot, 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 put what you want in there. Yeah, so what have we missed? So it ups the version. So what are you working on? Oh, I thought I explained it. No idea. Did you not hear? I thought I explained it. Sorry. Yeah. So essentially, I'm writing the documentation. So I've already written this encoder system. So I'm going to be using it for the editor to save out. So the next plan for the next 8 months is we're building an editor. We're going to make some assets in the editor. So I want to be able to save them out to disk, preserve them, upgrade, and everything. So we're making a description file because unfortunately C1 will not do, but it's very C-like. We're going to be able to output text files or binary files from this. The binary files would literally just be a data pointer to a buffer in memory, and we also support versioning and upgrading. And we have a system which will kind of have this on guardrails. So if you make changes and you've done something wrong, it will tell you like, this is how you fix it, or this is what you should do next if you want to make this change that you want to make. So for instance, you can't make change to data structures if you're doing a binary file. You have to up the version and then you can make that change. But it's going to be used for more than just files. There's different target modes. There's one for files which does the versioning thing, text mode or binary mode. It's got a GPU version. So we can, like, we've got this sort of like packed thing here. Which will allow us to take a U32 or a float32 or some other types, and those can get packed down into bits, and the conversion code will be generated automatically, and it'll be generated along with the structure. So when we're in GPU land, we can generate some really nicely packed stuff and not have to write the code that's very error prone. So yeah, that's basically the quick pitch about the system. We've already written the parser for it. We're just planning out the next stage of it because I didn't really think about it in enough detail, and I would like to make sure that everything has been thought out before I finish it. Do you need reflection data? How do you know it's zero struts? I would use a human readable. Yeah, exactly. That's correct. So in the past, I've done reflection. It was a pain in the butt to deal with serializers when you're dealing with like reflection information. Even if there's a bug in the serializer, it's a bit of a pain. So instead, we're going to code generate it instead. So we are going to use reflection data, right? We get the reflection data by parsing that .enc file. We've got the data type, but we're going to code generate the serialization code and deserialization code for the text file. And for the binary file, it's just going to be a pointer to the memory buffer, and we just manually convert that into the runtime format ourselves. Yeah, most of the data, you're right, should be in a text format. And that's what we've got here. We've got the ability to, sometimes you only want it in text. This is for stuff like config files, right, when they're shipped with the game. You may want binary files. This is kind of rare, but you may want it for really complex stuff like meshes and pixel data where you don't change the types too much, but the binary file will need, where is it? And if the data is not suited for text. But this is the main case, right? For development, we'll use text. And then like when we release it, we'll use binary for the speeds and stuff. But yeah. This is the way. Hey, Katsumoy. How am I? Not doing bad? Not doing bad. Yeah, pretty good. It's been, working, hanging around with the family. And my boy's nearly walking now. Able to hold him and walk around. But he still needs to work on that balance, but he's getting there. Yeah, things are going good. Went up to see my grandparents yesterday. It's pretty nice. Saw my parents today. That's pretty good too. Progress is going all right. This, I was going to do a very basic encoding system, and then I thought, you know what? If I do a very basic thing, it means it could be quite error prone. So I'm building a bit more of an involved system now that works. That's going to help me in doing GPU stuff in the future and also these assets. So yeah, progress is going all right. We've written a custom file for defining data structures and things, and we've written a custom parser for it. We're going to be code generating serialization and deserialization code. So yeah, it's going to be awesome. I'm just trying to refine everything about this system and just make sure it's all makes sense before I write any more code, because I've got to the point now where the details matter. So yeah, how about you? How's things going? You need the reflection data also for your editor. Oh, right. Are you talking about, yeah, when you, yeah, I see what you're saying. You have like a drop down, you have like a widget that represents editing that piece of data. Yeah, we might need that. Or maybe we put it in the code. Yeah, we'll see. Yeah, we might actually need the reflection data. Or we code generate it. I don't know. The top of the file is a target file, dev. What else about versioning have we not sort of documented, Ups the version number, you upgrade the past versions, right? Oh yeah, we want to talk about the binary and text thing, isn't it? So yeah, it's quite weird, isn't it? So for for text and for files. That's another thing as well we've got to think about. If you change that to support text files and binary, yeah, we should also write that down if we support that or not. So for files that exclusively export to a text file or a binary file, you know, the workflow is quite simple. The workflow is quite simple. If you break the rules, if you meet any of the if you need to make changes, make those breaking changes. So I use the word breaking, but not use the word breaking up here. If you make any of those changes which require upgrading the version, that require you to up the version, you put the file into dev mode, then make all of your changes you need. Yeah, so I need to write some things down quickly. Serialization. So dev mode, file name, differences, and then also the I need to do that one. Also, what happens if you change, or can you change to support text / binary? A nice man, you live in a dream, being a father and coding it for pleasure. Yeah, man. Yeah, very thankful for that. What else can a man ask for? I transitioned to C. Remote managing from C++, very cool. I bought a course for £60 on Udemy to learn C properly. I got frustrated because I was using sound effector and string everywhere in my code and I had no idea how to use pointers properly. Now that I'm rewriting stuff myself, I find working with pointers in C is kind of difficult using malloc, etc. But I'm getting there. Right, I got a link for you, my friend. Posted this on the Discord today, actually. Hang on a minute. Jump to the present. Basically, malloc is a very terrible API design, right? I'm not hating on people who made the design of it. Sorry for this blind and white screen, but obviously, you know, it was made in like the 80s or something. But anyway, check out this series by Ginger Bill. Pretty legit. So effectively, right, if you allocate something and then free something like individual objects, it's annoying. And that's why destructors kind of make sense in people's minds. But if your objects don't need destructing, then you could really free multiple objects all at once. And if you read these blog posts here, the first four are pretty pretty good. The last two are a little bit more complicated, and you probably won't use these. But you can. But the majority you'll use are the first few. This will help you think about memory, lifetime, and allocation, and how you can do it better. Highly recommend. This is what I do basically. And yeah. I have also, if you're interested in some of my past VODs, I have made my own custom arrays, hash table, and object pool. The VODs are all up on YouTube. If you scroll down to after the initial Vulkan stuff, so I tried to get graphics on the screen right away with this thing, but after we did the graphics, I did a virtual memory abstraction, custom allocators and a global array, hash table, object pool, right? And then I just wrapped it up and went on to keyboard and mouse input. So they're all there, right? They're all past streams if you're interested in checking those out as some other source of information. But yeah, that's about it. What? What do you mean Calloc? I never mentioned. No, 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 no. Malloc is an abstraction. There is lower level abstractions than Malloc. You can build your own version to allocate memory. Like, you need to learn about virtual memory as well and understand what that is. Yeah, there's probably good sources. Has anyone got good resources on virtual memory by any chance? If you can link those, that'd be great. Big help. Hey there, Kept Payne. How you doing, sir? Welcome, welcome, welcome. Yeah, files that exclusively support text binary, the workflow, that's all one word, isn't it? I don't know, it's quite simple. If you need to make changes, those changes that require you to up the version, you put the file into dev mode, make all the changes you need, then remove the dev directive. Your version will be upgraded. And then remove when you are done. So now what we would like to say is, if you support text and binary mode, when you put it into the whole file into dev mode. So you've been making little text changes. Yeah, so say if you're on version 0, v0, right, you basically have a text file. Sorry, everything's encoded into text representation, and you've been making your data types. They've been pretty cool. You've been, saving assets out and things, and then you're like, right, I need to ship some things. And you go version 1, right? So you put it into dev mode, and then should we say the next one is binary? And then when you go to make your changes, like you add and remove types. Yeah, so I think you would say, okay. Yeah, I think that's the way it's going to work. You put the file into dev mode. Right. The version will only get updated when entering dev mode. Right. So when your file type supports, or when you support encoding to both text and binary files. So how does this work differently, right? You could say, so when you put it into dev mode, maybe so that's to make the binary file or whatever. When you come out of dev mode, it will then up the version again or something like that, right? Yeah. So you know, when you enter, it works mostly the same. Mostly the same when you enter dev mode. The version number goes up by 1. Will go up by 1 when entering dev mode, right? The version mode goes up by 1. But when you leave, okay. You make your changes, and then remove #dev directive when you are done. When you leave dev mode, but when you have left, the version number will be increased again. See, this is a bit of a wrong way of saying it, maybe. Capcom had talk when they switched the engine over to virtual memory aware system. Unfortunately, it's in Japanese. Okay. It's also sort of let down because it boils down to we use memalloc. Did you Microsoft is going to SPV? Yeah, it's interesting, isn't it? Good. It's great. I like it. It means for my compiler, right, my custom C compiler for SPV, I can support DirectX with less changes now, far less changes, which is really cool. What is memalloc anyway? It's just some other Yes, okay, this already makes me cringe. General purpose, like 11,000 lines of code. What? Yeah, this is just a heap allocator. It's just cringe. I think, yeah, that's what you want to move away from. Like in 2024, that's the year. There's much better ways of doing things than malloc and free. Um, yeah, like arenas, like a linear allocator, bump allocator, stack allocator, pool allocators. You know, yeah, you got other allocators, right? But they're the main ones. Um, the version number will be increased again. You can think of it as text files. Um, right, so maybe I should say let's just delete that because that was already put above and they just would have read that. But when you leave dev mode, the version number will increase again by 1. You can think of it as text files are encoded when see, it's kind of weird though because you put it into dev mode and when you make your release, yeah, it's one of those things. No, 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 no. You probably don't. Yeah, 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 yeah. Because you write your against the odd numbers. Odd numbers are binary files. Yeah, you could think of it um, as text files will be encoded with even numbers, even version numbers, and binary files will be encoded with odd version numbers. This is so that see, if you put it into dev mode upgrade, you're going to say that. Okay, that's okay. Yep. So going from a version 1 to a version. Yeah. Okay. This is so that that we can upgrade text or binary files to the latest version. Yep. Using the upgrade path or whatever, right? Using the same upgrade code. Well, that doesn't really help. Okay, this is so that so we're doing this odd and even thing. This is so that when we are in development and make changes to the text file, it will not ruin the binary file that we released with. That's what this is saying. This is so that when we make changes to the development text file, it does not ruin it does not it's not really ruin. So if you have a binary file, we will not be making changes to the binary file data structures or data types, something like that. Right, so something we'll talk about as well as the actual upgrade stuff. Oh yeah, buffer overflow, I already linked it in the chat. Hey buffer overflow, how you doing? Files that exclusively export to a fun. Yeah, files that exclusively export to a text file or yeah, but they never say exported. Yeah, I've got to put R before there, and I want to have the word exclusively in there. I read fine as it is, unless you're talking about a different place. I don't think so. Hey, Drove Stead. Yeah, not doing bad, man. Not doing bad. Thank you very much. How are you doing? Right. Okay. Oh, get in there. So, dev mode file name differences. Right. Yep. So while you're in dev mode, while you are in dev mode, you are going to be changing the data types and invalidating oh my days. Oh, what's up with my damn spelling today? There we go. You'll be invalidating any assets or any files saved out with this version. You're going to be changing data types and invalidating any files you have saved out while in dev mode. To fix this, files in dev mode, files saved out in dev mode will be suffixed with dev hash, where hash is the hash of the data structure. The data type itself. Data type fields or something like that. Of all the information about the data type itself. This will allow you to test retest the upgrade path, from the previous version by just deleting the file, the dev files, or changing the type itself. And also it will prevent you loading any invalid data. This will prevent loading any invalid data and allow you to retest the upgrade path. So that's pretty legit. The next one is, I'm doing well. It's been a nice calm weekend. Met a friend yesterday and we're out talking a coffee. Yeah, having a coffee and chilling downtown. Cool. That's very relaxing. That's something I've not done in a while, is socializing. Yeah, very rare thing I do these days. Yeah. Fair play, it's cool. Sounds great. Yeah, I saw my grandparents yesterday. I went up with the boy and he was walking around the front room. I was having to hold on to him though. But he's getting there, his balance. Balance needs a bit of work though, but it's cool. I saw my parents today. So yeah, it's been catching up really there. If your licensing is free MIT, we change it to avoid the WordPress situation. What is the WordPress situation? Would you care to explain, please? So now the next question is, if you put your file, so you've made your own file format using this encoder system. So you've got one .enc file, which you describe all the types for a single file that you write out, or a single file type. So that's another thing I've not written down. We should probably say each file type. Sorry, I think I want to say one file. Yeah, I'll write that in there. One ENC file equals one file type. Yeah, so can you change between, so when you have your target file, binary target file text, or binary slash text, you support both. Can you change that? Well, if we've got a different sort of version skipping thing here, if you're a different sort of version skipping thing with this one, you're not really going to be able to follow that. You know, what happens if you've been making it a text file and you're like, right, I changed my mind. I want to make it now a binary file too. Well, you've gone and made a whole bunch of versions which are not binary in the past. Would that matter? Well, it's just an upgrade script that runs, right? But the rule, but I think when you write it in, when you try and read a binary file, it'd be like an odd number or something, isn't it? Yeah, so I think what we'll do is we'll allow you to change it, but if you change it between text and binary or whatever, it will. Would I have to add 2 new versions? You know what? We won't allow you to change it. Set in stone. Yeah, well, if I need it, we'll add it in. I'll think about the problem then. I don't think we need to. So the answer is no. You cannot change it. A file needs to choose this cannot change. I need to stick that somewhere. I need to choose that at the beginning. Yeah, I'll do it. Yeah, so I think so my game is gonna be the source code will be provided. I think the license I've got a custom license, but I'll probably revise it. But effectively the code can be looked at, it can be edited, it can be shared to people who have also bought the game. But you cannot, like, you can study the code and learn from it and use it in your own projects. I think I might take the engine folder and just say, hey, the whole engine folder is MIT. I haven't done that yet, but I might do that. But the rest of the game will be like, you know, you could take bits of it and use it in your own code, but just don't, you know, you can learn from stuff, like things in it, but you can't really copy paste it and just like use the whole thing, you know what I mean? So that's the kind of license at a nutshell. Because I want I want this project to be able for people to modify and share, learn, and create their own stuff from it. Like, or be inspired to learn and create their own stuff. That's what I want to give away. It's kind of a bit of a different take on things, but because, you know, things are a bit closed source, and I don't think we're doing a good job in the industry getting people into programming. Maybe not some of the industry's fault. School's pretty crap as well, right? There's many compounding factors which make the fact that we're not getting enough good programmers out there. So I think I want to try and do my bit basically, and I think if I at least release the source code when people buy the game, it might inspire some people and to modify and then learn and maybe do more. You know. Yeah, I'm not fussed about, you know. I think when you release for PC, stuff's just gonna get pirated anyway. So hopefully we can make a console port of this for different consoles and things. But yeah, it's gonna happen. Pirating's gonna happen and things. But the idea as well is I think is I want to make it such that maybe people can play with their friends for free without buying a copy of the game. Because it makes people, you know, it's a showstopper when you can't play with your friends. If your friend's got a game and you can play with them without buying the game, it's pretty awesome. And then maybe that person's like, this game's pretty cool, I'll go and buy it. I think it's a real challenge at the moment. Kids are not nagging their parents to buy games. Kids are nagging their parents for coins. So, yeah. You have to create an incentive for people to nag their parents, basically, or actually buy something. And then you will have an audience which will buy your game initially. And I think those could help drive more people to buy your game. That's my thinking on the whole sort of open source aspect of this, and yeah, having the code be available but also monetizing it. And also, people aren't really going to want to compile your game from source, download all the compilers and things, and get that on their system. On Windows, you have to install some things. And it's a little bit more effort. Some people would just be like, I'll just buy it. And people like stuff in Steam and things. So if you got it in Steam, people like having it in the Steam library. Right, so that's pretty cool, that suffix thing, I like that. We've solved that problem as well. So we need to mention somewhere that for at least the file target mode, there's only a single file. A single encode file represents a single file type. So you can obviously encode multiple files with the same type, but because when you change when you go into dev mode, you're up in the version for everything in that file, right? And maybe we'll put a version. Yeah. Oh, that's another thing about versioning. We want to encode a version in the version encoded in files. That needs to be mentioned too. So, what do we mention this thing? So, So we want to say in file target mode, a single .enc file represents a single file type. Something like that. I think that'll be good enough. Cool. Next one, version encoded in files. So the version number is encoded at the top of the CSON file, like so. Version x, oh, dot dot dot, right, it's just an integer. As an integer, so, and then we say the version number is encoded at the beginning of, and then we can say like for a binary file, for a binary file, we'll have a version number and a checksum to check for data integrity. You see, do we want like a magic number or anything? No, I think the checksum, magic number you use to identify the file type, but I think we're okay without the magic number. If you just have a version right at the top, followed by the checksum, we can just checksum the rest of the bits and we'll notice it's fine. But if they change the version number, yeah, so the checksum will probably include the version number as well. The binary file, we will have the following header: strut bin header e32 version e32 checksum. So obviously the version numbers are there. The version number exists so we can avoid loading newer data and upgrade from previous versions. And the checksum will act. The checksum will act as will ensure that our data has not been modified. See, you still need to make sure you put necessary checks around any data that you load into memory, because someone could it's just the safer thing to do, right? They could change the file, rewrite the checksum out, because they'll figure that out. and then it will mess up your system. Oh, sorry, be able to exploit that basically. But yeah, it's just a general way of knowing, telling the user that that their assets are corrupted. Will be a way for us to tell our users that the asset is corrupted. We still need to properly handle invalid data when reading from asset files. When reading from encoded files, for security purposes. Right. Yeah, because right, that's fine. So we could say like, the text file doesn't need it. Doesn't need the checksum. Does not need the checksum since its whole point if that one gets busted, well, you figure out if it's corrupted by the parser, right? The season file does not need the checksum as the parser will tell us if it is corrupted. Cool. Nice. What else? Upgrading. Like, we've already mentioned about upgrading in terms of like how you do the version, but the actual upgrade code. So what we need to say actually before that is text files. Where can I put this? When loaded into memory, or text files will be we want to say like text files are this is under the versioning and upgrading side of things. So I think we're getting there now. So what about the upgrade? Let's write this one down quick. Text files are maybe I can write a new header or something. But yeah, so upgrading. I guess the user will be upgrading will be a rare thing. The user will be in charge of upgrading their file. And the way upgrades will work is that it'll write, we need to write that. This talks about versioning. We talk about the upgrade process. I don't know. Yeah, we haven't really spoken about upgrading yet. So when upgrading, so we can't really code generate anything helpful. We can maybe code generate going over types or something, but right, okay, so so what we need to say is that when you load the game up, or maybe you run some other program or whatever it is, old assets will be upgraded to the newer version. Yeah. So in I could just say, when the game boots up, it will check over all the assets. Yeah, maybe do a lazy upgrade. And then we can have another program that actually maybe we'll make it an external program. I'm not sure where I want to stick it. Right, let's just do it in the game. When the game... Let's just do it lazily. When the game loads an asset or loads a file, or tries to decode a file and the version is older than the existing one, than the current one, right, we need to say that it gets loaded into memory first, and then we... Right, okay. I was going to take a quick break, 2 seconds. BRB. Right, welcome back everybody. Hey hostman, how you doing? Welcome. Oh, right. So I haven't talked about the process where files will get fully loaded into memory, and then if they're binary, they get loaded. Yes, we'll probably do it here, right? Every file, every binary file is fully read into memory. See, oh, where can I stick it? It's just, because for the networking and the other ones, let's just write in here. Yes, every binary file is fully read into memory from disk, and then a pointer, right? And a pointer to the root object will be used to manually process the file, right? Something like this. Every binary file is fully read into memory from disk, and a pointer to the root object will be used to manually process the file. This enables us to deserialize or to decode the text CSON based files into the binary file in memory, right? This enables us to decode the text files into a binary file in memory and use the same system, the same loading code, or the same system for both. The same processing code. Pretty sweet, huh? So a lot of docs. How's this looking anyway in the browser? These are not really easy to see, these headers. Yeah. Oh well. They should probably call it target mode file. Something like that. Target mode net, target mode GPE. Yeah, so that's pretty nice. And because we're using the binary, the binary files will be used to unpack, or the binary Yeah, I'll leave it at that. Right, so in this upgrade section, this was it. When the game tries to decode a file and the version is older than the current one, it will take the in-memory binary representation as input to the upgrade function the user has created. Maybe say that a different way. The user creates... so we need to provide upgrade functions somehow. So we might, I'm not sure how I'll do this, but maybe the user will need to handle, you know, they'll get a version they load in and maybe it's like a switch statement or something. I don't know. The user creates their own upgrade, function that will take the binary representation, the in-memory binary representation of the file and emit the new version into a new buffer. This new version will then be saved out in its place, maybe in its place. Saved out in its place and then used. Well, maybe after you've processed it successfully, perhaps, then it does it. Yeah, so if the user has a way to do the upgrade, process the data, but maybe the data processing doesn't need to happen, right? You just would like to just keep the memory around and that's it, it's done. So perhaps the validity, yeah, the code just has to be tested. Yep. And then, you know, the normal process, and then the process of manually and then the manual processing of the binary file continues. Then the standard process, or then the standard process. This version will be saved. Cool. So anything else about the upgrading that we need to talk about, really? I think that's kind of it. Yeah, I think that's it. That's pretty good. So yeah, that's all versioning, upgrading, very nice. What is some of this stuff? So this is talking about specifically to do with how we read the data in. Right, this is like the decode process. That can stay there. this is talking about the different file formats. And this is talking about the, so maybe I could put a header for this, the formats. And then this one can be format, something like that. Cool, so looking good. So we've got like a formats section. Maybe these should be capitals, right? Pretty sweet. Okay, that's really good. So what are we missing from this sort of target mode file thing? Like, we haven't really spoken about structures in general or unions or really like the types things. Hey, so Kenny, how's the game engine going? Yeah, it's going alright, man. Just designing sort of the encode file in more detail, this encoding system. Because I got to the point now where the detail really matters, and so we just ran out some documentation to deal with that process really. Just really thinking everything out before I write any more code. And yeah, I could have done this before because I'm a lot more educated on the matter now after writing some code. But yeah, doing good though. How are you doing? How's the have you been looking into SDL3, was it? Or, you know, did you start on that software rasterizer in the end? Right, so we still haven't spoke about like what structures are unions, enums. Maybe I could do a little blurb, a little thing at the top to say like, what does this system do? Well, it code generates mm, there was the decoding step here, wasn't it? Yes, it's the decoding step. Decoding and encoding. File decoding / encoding. So we want to say the text CSON files are by calling the code generated functions after running Something like that. Let's just jot that down at least. Binary files are encoded in place, are manually encoded in place or into a buffer by the user. And then saves out to disk. So then you provided the buffer, it will do the checksum and put the version in. Then call, let's just make up a function name. You know, file save, and maybe you'll do the special something else. Maybe we'll do the special saving trick as well, so it's safe. Save, which will put the right version in, put the version number in, and the version and checksum in. Something like that. Yeah, something like that. Which will populate the version and checksum fields before saving. There we go. Nice, I'm currently focused on new stuff, to be honest. Maybe when I get a break, I'll take a look at software rendering. Cool, and again, thanks for the links and resources provided, especially the memory allocators resource. No problemo. That's cool, man. Yeah, you might as well focus on that uni and make sure you know, pass and achieve what you want to achieve there. That's fair play. That's cool. Cool. Right, so we're still got to talk about like structures themselves and like this is just the target modes, right? The different types of target modes, maybe we put some of the sort of more common-y bits here. We've done and target modes. So maybe we should talk about the actual sort of like the language itself, right? Data types. Yeah, we should think about. Yes, I'm pretty happy with this file one now. I'm not sure if there's anything. Maybe I'll think about some more stuff. But we've got GPU and networking to do. And this sort of target mode features, we'll think about those as they come. Right, let's just write out some of this sort of like languagey stuff. So when it comes to actually writing out the encode file, right? I don't know whether this documentation should come first or not. The target modes. Target mode binary, and then it talks about like these different target modes, and then all sorts, versioning, upgrading, how it all works. But then maybe we should just talk about the data types first. Let's do that. So we've got obviously your built-in types. You got your basic types. Basic types. Yeah, you got your unsigned integers. U8, 16, 32, 64. Signed integers. And you got your floats as well. You got the Boolean type as well. Bool. Got your floating points. Still going, cool. F32, F64. I've not really done the F16. We'll probably manually bitpack them into integers anyway. So after that, we've got some intrinsic types. We've got vectors. So vector types. These are built in. So they're essentially like all the ones up there. Yeah, well, times 2, right, something like that. See, I don't know if I should categorize them like that again. Maybe, I do have them in the generator. Yeah, maybe I'll get all these in. The vector types. That's all built in. See, these lists get quite long. Oh well. Lowercase. All right. And the other one is kind of like some other intrinsic ones, like MISC intrinsics. So our matrix 3D. Transform 3D and a quaternion. They're built in. Right. So other than these guys, we've got the structure types, structure and union types. Right, so we've got a structure type, which is basically like a you know, pretty much But also support variable length arrays and things, isn't it? Where's VLA? Yeah, we should mention these things. Right, so strut example. Then you can put your directives here. So I forgot what directives we're going to have now. There's probably one for bit field, which you declare the bit field. E32 array 10 E32 variable length array. Right, you can say, as you can see by this example, it is basically it is very similar to C. But has some slight we should talk about the packed types as well. Has some slight differences, I guess. Has some additions and omissions. Oh. Cool. We should talk about that packed type, to be honest. That's pretty cool. Packed type. So you declare it as something like so one of the main things we want to be able to express encoding and decoding data down into a series of bits. Integers and floats down into a smaller series of bits. You know, the packed type allows you to pack allows you to express bit fields. Should we say bit fields? Because you're only going to have these in structures. You're not going to have them in unions. Because there's no point in them being in a union. So pack type allows you to express bit fields and a sort of like a range. How many bits? You want to pack down to, followed by a minimax value. This will allow the system to generate packing code, packing and unpacking functions for your structure. For your structure type, automatically so example U16, we'll say it's a field of, it's really when he works with the structure. Pack types only work on structs. And they kind of act like a supercharged bit field, something like that, like supercharged bit fields. Example, so we'll say field A. What's syntax again? Yes, you say B. B8, 100, 300, float 32, field B. Let's say this one uses 24 bits. So we'll call this example. We'll do hash bit field and we'll do U32 like that. And then we'll say something like, we'll just put a regular field here. So field A, we'll call this one field B, field C. 24 bits, and we're going to go between the range of 0 and 100, for instance. So as you can see, okay, so we'll say field A is just a regular, field A is just a regular field. Regular field. Field B is the is a U16 that gets packed down into 8 bits within the range of 100 to 300. Is it inclusive? Yeah, I think it's inclusive. Yep. Inclusively. Right. Field C is a float 32 that gets packed down into 24 bits within the range of 0 to 100. Now, so we could then say the smaller the range, the more precision, the more bits, the more precision, right? Did I do some checking to make sure it will? Yeah, I think I did. It's just, yeah, so the more bits, the more precision, the less range, the more precision. What else do we need to say about this? We could then say this is what the data structure looks like. The bit field U32 or T means that bit fields will be encoded, will be rounded up to the near. What are we saying? They'll be aligned. Bit fields will be aligned to type bit fields word size and alignment will be U32 or be, of type T. Well, T is a basic type. I didn't say that about the thing as well, did I? Well, I did. I said it must be integers or floats down to yeah. Where T is a basic type. So as an example, and then I should also say bit fields can, you do not need to worry. Bit fields can overflow. Is it the word overflow you see? Can span over. Can span over multiple words at the cost of decoding / encoding or unpacking / packing performance. Because yeah, we want to be able to do that, and I want to be able to have something that just code gens that. because doing that manually is just a bit annoying. But yeah, that'd be really cool. So I guess I can now just say, here's an example. Here is the example of the code generated structure from above, version of that structure. Here is the of that structure in C. So we'll just do something like type def strut example. And then we can just say something like field A. Now these are the bit fields. So I don't know what we'll call these, to be honest, but we can call them words, I guess. And if we put different, maybe you call them bit fields 0. And if you do another set of bit fields, it'll be bit fields 1. Right, but there's your bit field 0. They all pack into one bit or one word. And maybe we do, I don't know. But anyway, we'll make some functions where you can say, so you get a U16 back, right? This will be example field B. So you pass in example corner, and there'll be an implementation which will do the unpacking. Then you get a field C, like so. So that'd be F32. Will we have a way to manually set these? I think there might be a function which constructs it, I guess. Maybe we make it snake lowercase type of deal. And for this, you'll pass in every element. Field A, U16 field B, F32 field C, and we'll just construct the whole object in one go. And that's if you have bit fields in your structure. Yeah, only generated. If you have bit fields, you can pack it like that. Cool. Yeah. If I need to change it, or if I need to change this whole, obviously, this is not the end of the world, this stuff, I think. Always change it. Or extend it. Right, so I didn't mention about the VLA type for the structure, VLAs. You know, there is the VLA type or VLA field. These things are, it's type. So structures, strut types support variable length arrays. So variable length arrays. When the sort of array size, array count uses a field name instead. of an integer. So we need to say that when it's encoded, and we'll say here is an example of a code generated version of that one above, of that structure in C. So we'll say that VLAs will, the VLA field will be replaced by a U32 relative offset. Have I spoke about this relative offset yet? I don't think I have. I have here. Yeah, and we speak about the reasons why. In there, yeah. So the VLA's fill will be replaced by U32 relative offset, where that will relative byte offset or something like that. That will point to where the array is, or from this field's memory address. This can be used to access the array using the code generator function. Right, so here's an example of the code generator code. So we've got this struct called example. We are simply just gonna, this is gonna now be a U32 VLA 0, and we're gonna generate, or VLA byte offset, something like that. So you take in a pointer, you'll get, the type is a U32 that returns. You say VLA example VLA example they're not VLAs, they are variable length members. VLAs are stack arrays. Yes and no. That's just like your understanding of it. Like if you think, just take the name, right? Variable length array. What is this? It's an array. What is its length? It's a variable length. So this qualifies as a variable length array. So yeah, I am kind of overloading the term a bit, but I think calling them a different name is not worth it. So this will just do something like a cast it to a U8, right, bytes, basically. Well, we could do char as an example, but I don't know. Apply the byte offset. Then cast that into a U32. Neat. And voila. So we're just going to code generate all that automatically. Pretty cool. We should probably give this a U16 or something, just slightly different, so it doesn't get a little bit confusing. Right, that still stays as U32. That'll be U16 and that'll be U16. Right. Nice. Yes, that's pretty cool thing to support. Anything else about structures that we might have? Fields can have hexadecimal. Format inside. Structure field directives. This docs from metaprogram. Yeah, so I'm just writing out the so we've already written out a custom file. We're not, ignore this table thing for now, but it's basically a way of describing it's basically a way of describing a some types that I want to be able to serialize to text or to binary, but also support versioning because I'm going to be making an editor. So I would like to preserve my assets that I make and be able to upgrade them. But also I would like to use this for packing and unpacking stuff for GPU data types. So a very common thing that I have is I want to pack things down into small, basically have bit fields that are better than bit fields where I can pack floating point values down. And I want to have a way to do that. So yeah, I wanted a way to do that like a lot easier because my main issue is that's quite error prone to do and it takes time. And it'd be good if we could just do it within seconds, basically rerun the code generator. So yeah, it's just going to help me in those areas really. So this whole system has been designed to work for those cases really, and probably networking as well in the future. So packing stuff down basically. This is why it's called the encoder and decoder system. So I got to a point now where I can parse that file. Get all the type information, but I just need to really refine a lot of the details out because I had a bit of a design. But I was getting to the point where I was like, this is not really making 100% sense. So before I carry on, I would like to really just refine everything. So I thought the best way is just literally write out the documentation for it. Because this will allow me to really think about every aspect and make sure that it doesn't contradict anything before I carry on. So yeah, I'm just really thinking about every aspect of this, making sure it makes sense because it is quite complicated. But it's gonna help save a lot of time and mistakes. The struct field directives, we've got hex. What else do we add? I think that's about it. It's just hex, isn't it? Oh shoot. Encode gen. Yeah, it's just is hex. There's a removed one. But yeah. So for text files, yeah, it's really got to be for integers only, isn't it? Did I do that? Yeah, only really works for integers, doesn't it? I don't think I did a check for that, but that's okay. Yeah. Hexadecimal text encoding. So structure fields. structure fields that are integers can specify that they should be encoded as hexadecimal when being encoded as text CSON. Here's an example. A ball E32. We'll call it a mask, hex, and voila. You know, if we have any more, we'll obviously join it all into one section. But for now, I've only got the hex one, so we'll just leave it at that. But yeah, it's pretty alright. Sweet. So what else about structures? The only other ones we've got is enum and union. The union should really go next. Like a union type. And then an enum. So unions are going to be tagged unions. Just because, like, how else are you going to decode it otherwise? You probably don't need to put the tag in the text file. But maybe we do. Yeah. Is there anything else about the struct that I need to put into the structures? Right, we've spoken about, we just read the point here, we take a direct pointer. This is mainly just talking about the actual syntax of the file. But yeah, that's cool. So we're going to say unions are all unions. See, there's no point of having a union which is a standard union in C, right? Because so for a text file, you would know based on, or maybe we do. Maybe it does make sense. In a text file, you'll know based on the type. The single field that is initialized in the object, you would know which one it is. For the binary file, it would be padded. You know, it's just in memory, isn't it? So it might work out okay. Yeah, maybe we don't do tagged unions. Because we could have our own tags specified in bit fields or something, right? Really packed down. And not waste a whole 4 bytes. Or maybe you do 1 byte, I don't know. Yeah, so we could just say yeah, I think we'll stick to regular unions. Tagged unions are not needed. So is there any other problem with these tagged unions? Or sorry, these standard unions? Yeah, so my main problem, the reason why I did the tagged union, I guess, was for networking, right? You might have let's get to a C file. if you were to do like a network packet, you might have like a union at the end. So you have like your packet type, which switches on your type of packet. And in here you have maybe like a sort of like ping packet, or I don't know, connection request packet. And these are all different sizes, right? But you don't want to send the whole structure. When you decode, you just get pointed to the structure and you only read the data that you need. But when you're sending it, you only really want to send what is required, right? So I was thinking, for this system, could we automate the process of giving you the size that you've used? So I'd read the packet type and I'd be like, oh, this is, tags union. We're only using connection request, so just send up to the end of connection request, right? Maybe that could just be done manually. We probably won't need to do it a lot. Yeah, I think we'll opt to doing that manually then. So you would switch on it and just take size of the structure and do that, I think. Right, so we'll just say like basically they're just like we'll just say it supports C-like unions. I don't think there's any hash things that work, like any directives. Well, there will be the hash or the hexadecimal directive. Ugh. That probably wants to work with unions. Hmm. Hmm. We could say, like in C, unions are untagged. Yep. So integer, and then we'll do a float. Cool, there's nothing really exciting about that one. Enums. So for an enum, you see, when we generate old versions of things, enums are going to be quite tricky, I think. So if you've got an old version of a file, the enums that are used in that file, and really the things have got to be suffixed with the version, and then we'll obviously have one which is not suffixed at all, and that's the current version. Maybe we'll just have suffixes. So when it comes to the enums, typically you do your own sort of like prefix, right? But yeah, if we're going to be put in versions, realistically what you would like is a sort of like version number in there as well. But maybe you could prefix the whole thing with v0. So maybe they could be prefixes instead. If they're prefixes, then we don't have to do anything special. So yeah, maybe that's what we'll do. So the version can be prefixed at the beginning of every identifier. The current one it gets a bit ugly, but so for files, you need versions for upgrades, but the rest of them don't need it. So what we can say, this will be good. So in that target mode file, we could also say like versioning yeah, maybe it should go in here. So we could say every generated data type for the file target mode will be prefixed. Will be prefixed with the version number, like so. So you would say so you would say something like example. So this is defined in the enc file, and then you'll say this is the actual generated code, generated strut name. This is so we can support upgrading using the data types directly. So in the encode file, you got this like that. You'll have like a field 0 and a field 1 or something. Then the generated one, there'll be like a version 0, which only has a field 1 or a field 0. And then version 1 yeah, it's a little bit ugly, but it's alright. It will do. Solves the problem. Makes it okay for enums as well. Yeah, I think that's alright. So where's that one at? Enums. Right, so again, we're just gonna do it. They're just gonna support. So they're just gonna, as you can see with this example, it's very similar to C. Where's that? Oh, but we also support the underlying type. Damn it, my laptop died. But we also support the underlying type. And we also support the underlying C23's underlying type specifier. Specifier, but we generate this with type def. But we generate this with type def as we, don't use C23. So that'd be pretty cool. So this is actually finding the encoder file, and then so imagine if we did this one off at dragon -2, and then this would be the generated code, C code. So you get a bit of a type def, S16, ent type. Oh. Cool. What else? Why is this? Okay. Yeah, so this will then be explicitly done out -1 and then minus. No, that ain't gonna work, is it? Sweet, look at that. Cool. Right, so we're getting pretty close. I didn't bring that type def actually when we did the other example. Let's sort that out quick. Right, so it's looking pretty good. We're getting some good documentation done. I'm not sure how close we are to being finished. Let's have a bit of a look, right? Right, so this is what we've made today basically. We've got the encoder system, the encoder file, data types, boolean, integers, signed ints. Oh, these are not done properly. Let's sort that one out. Nice. Right, so we've got the vector types as well. It's a little bit long, but oh well. Some other MISC intrinsic types are just built in. We'll talk about the structure type, the VLA side of things, the packed types, the hexadecimal encoding. This really is supported on the Union as well, though. So it is support on the Union. Let's move out to its own thing. Strut and Union fields. Strut and Union fields. And if I have any more of these, I'll make it a bit more generalized. But that's okay now. Alright, so move that around a bit. That are integers. Can specify that they should be encoded as hexadecimal when being encoded as text. Cool. So they can do that like that. Nice. So these are these target mode things. We talk about this. One of the target modes is this file target mode. What are the when it's saved as text, what are the restriction? What things can you do without updating the version? What things you can't do unless you upgrade the version? Wait, where is it? Crap. This didn't read well. Hang on a minute. Yes, this needs an extra new line in it because markdown. Everybody. So maybe put a bit of a header in and we'll call this the text file limitations. Edit text file editing. Updating types for text files, updating types for binary files. Updating types for text files, Windows codes as text, right? So here's the stuff you can do without updating, these are things you can't do. Then for, oh, this one done it as well, isn't it? New line. Here's the things you can do for binary files, right? You can change the field names. But yeah. But you're going to add and remove fields, you have to update the version. We've got this format stuff here. Versioning. So how you do versioning basically. So we put it into the whole file into dev mode and you can make your changes. What are, you know, how some of that stuff works. What am I doing with this? Oh yeah, it's prefixed with the version number. Yeah, so it's just saying how they get prefixed for this one specifically. Upgrading, we talk about that. Cool. So I've got some brief explanations of the networking target mode. There's nothing really special about it. The file target mode really talks about a lot of it. For the GPU one, we can just say, So yeah, for the networking one, we can just talk about how it's like it would just generate a bunch of structures that you just fill in place basically. Yeah, we'll just talk about how you expect to use it for networking, right? You get the buffer, you cast the pointer, and you just use the functions that have been generated if there are any. GPUs, similar sort of thing, right? You've got your, yeah, we can talk about that. And then there's these target mode features. Oh, damn this thing. Where some of the features are turned on and off depending on which target mode you're on, like variable length arrays, they're only on for files, or they're not on for. We describe why they're on and not available. So, right, we're getting pretty close. I would just like to finish off. Yeah, that hash packed thing is pretty sweet, isn't it? We need to do that. Cool. Yeah, maybe we should quickly just do it now. So networking. You know, where do we mention in the documentation that binary files are read? Yeah, I think we'll do something like this. We'll say when data is being binary data will be when reading packets from the network stream from the from the packet buffer, the user will cast the byte stream into the code generated structure, root object structure. See, that's another thing as well. We need to mark the object as root. And you need to do that for what do you need to do that for? Well, no, you need to do that for the file. That's the one I was missing. But yeah, so we need a way. We need to mark. Where's the piece of code? Or the docs? This one. In file target mode, a single ENC file represents a single file type. So you must specify the root structure, and it has to be a strut. The root structure type. Yeah, it has to be a structure. like so. With the root directive, yeah, we definitely need that. And you can only have one of these. Nice. So we'll just say like, you know, ... we'll leave that in there. What else? So it can't be a union, it has to be a strut. We could say the type is then, so this is the encoder, defining the encoder file, and then we do the generated one. Generate C code, and that is prefixed by that, we can call it the header or something. Bin header. Yeah, we could say you must specify the single root object strut type with the, yep. The generated code also contains a header field with the version and checksum. Yep, with the version and checksum. Header field inside. Cool. All right, so we're going back to that networking thing. Let's quickly finish this one off. While reading packets from the packet buffer, the user will cast the byte stream into the code generated root object or into their code generated packet type. You can have multiple of these, to be honest, if you wanted to. Yeah. I think, well, no, because it might have the version in there. I think you can do that yourself. Maybe. Yeah, you can do it yourself. The user will cast the byte stream into the code generated structure of your choice. Okay, from, and manually process the packet themselves. When writing packets to the packet buffer, the user will cast the byte stream. So I guess it's the same thing. Right. So for GPU, effectively, you're just going to get a bunch of structures with a bunch of unpacking stuff, right? There are limitations for GPU, like everything has to be 4-byte aligned. So we haven't specified that. We should put it probably, GPUs, since we want to support a wider range of GPUs. Where did I write that in my thing here? Oh, I forgot about that bit-filled one. If bit-filled T is unspecified, if is not specified, then T will default to U32. Nice. Right, glad I remembered that one. So for GPU, since we want to support a wider range of GPU hardware, we are limited. We are restricted to basic types of U32, S32, and F32. Yeah. What else? Bitfields will always be a U32 word. And vector types, must have the same restrictions. Same basic type restriction. Cool. So there's that limitation there that's kept in mind. We also have the thing where we never take things by a pointer. The other difference is that the code generated bit-filled unpacking functions are always taken by value instead of via pointer. Also, the GPU does not have pointers, so all the bit-filled unpacking generated bit-filled unpacking functions are by value instead of pointer. Instead of by a pointer. Yep, which is fine because everything gets inlined anyway. Yeah, it's looking alright. So what else are we missing from this documentation? I think we're pretty close. I think we've sussed out a lot of things, really. Like the main thing was this file target mode thing. It was really, in the versioning, dev mode. Oh, so if you want to up the version in net, right, you probably specify the version at the top of the file, maybe, and you can't go backwards. Yeah, I wonder if we should do explicit version number in general, you know. Yeah, we. If we did like our own sort of hash version instead of doing that sort of dev mode thing, hash dev, maybe you go version 1 dev. But it's. Hmm. Hmm. I don't know, I'll think about it. So, what a few outstanding things. We want to do sort of a packed thing. Talk about these sort of target mode features that exist in some different target modes and don't exist in others. There's this packed thing. I also want to talk, figure out net target mode version. How do we specify the version? Specifying or upgrade or upping that version. But I think we're basically there. I cannot think of anything else. These are the two things that are left. So yeah, I think in the next stream, we might literally have to figure out two things. But there's probably going to be one or two more things I just think about over the next day or two. And then we can get back to actually getting this thing done with the slight new direction of things. Maybe I'm going to remember things as I start doing things, but what about... Yeah, I think it's all kind of quite basic, to be honest. Right. Anyway, I think about it off stream. So yeah, that's the documentation side of things coming together. Pretty happy about it, to be fair. It's made me think about a lot of things. And not make it as complicated as it could have been. It's really write out the rules. But these rules will be expressed in the database, sorry, in that encoder system. I guess I haven't written about the encoder system in here, but I'm not really fussed about that yet. Oh shoot, what is that? So we haven't written about the encoder system that we're writing. Like how the system's gonna you know, watch your back. Basically, it's got the database file, right? We haven't really put that in this documentation here. Maybe we should also talk about the .enc database file and maybe the encoder gen validation stuff. Write some validation to make sure you don't do anything wrong. And it tells you how to carry on. Yes, I need to mention the validation, probably the database file, and a few little things there. I think that's basically it. Yeah. Right, getting super close there. That's really cool. So yeah, I'll next be on Tuesday at 7:30 p.m. GMT +1, same time on Thursday, and on Sunday, 4 hours ago, next Sunday. There's a Discord channel if you want to come and hang out in the meantime, where I usually post stuff. Other people post stuff. We have chats about things. But yeah, I'll share a link for that one. And that's about it, really. Thank you, only having fun. Appreciate it. Yes, got a lot of my, I'm quite relieved having that all defined now, because I was thinking like things really undesigned at the moment. And it's kind of sucks. But now everything's a lot more defined. I can now relax. Great, Tim. It's in Tim for a while. Right. Have a great start to your work week, everyone. Yeah, I'll see you all in a future one. Thank you for popping by. And yeah, catch you later.